Welcome to the Real Python Podcast. This is episode 241. How do you learn the terms commonly used when speaking about Python? How is the jargon similar to other programming languages? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We discuss a Python glossary recently created by Trey Hunner. Trey describes it as an unofficial glossary and Python jargon file. We dig into the terms and colloquial language often used when describing Python. We cover a blog post celebrating 31 years of Python by compiling Python 1.0. The piece walks through the hoops of finding the source code and standing up an old version of Debian. Once compiled, they open the REPL and find it surprisingly capable. We also share several other articles and projects from the Python community, including release news, a Python enhancement proposal roundup, managing Django's queue, a course about NumPy techniques, including practical examples, getting platform-specific directories, detecting which shell is in use, and a project for sorted container types. This episode is sponsored by Postman. Postman is the world's leading API collaboration platform, and they just launched Postman AI Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So we are digging in with a whole bunch of news. In fact, there's so much, I've decided I'm going to just take some of them off your plate.
You're going to participate this week?
Yeah, I mean, there's a bunch of peps, and I thought I've talked about some of these already, so that'll be fun. We got our regular topics and some projects. Yeah, and we're going to actually talk about a lot of old stuff, which I think will be fun. And jargon, which I think is going to be fun too. So are you ready to dig in?
Sure. So like you said, plenty of news to start with. There's a few releases. The first one, kind of the one you probably expect, Python 3.14 Alpha 5 is out, so they just keep chugging along. On top of that, PyPy, the alternative interpreter, released 7.3.18. This is their first release that's compatible with Python 3.11. So they're behind CPython in what they're compatible with.
Did you just say 3.11 or did you mean 3.13?
3.11. No, it is. They're usually a couple versions behind.
Yeah.
And they've marked 3.11 as beta because this is the first time they've done it. This release also includes 3.10, fully compatible, and they still support 2.7 as well. So this is why it takes them a while to add the new language features, as they are still playing with the other pieces as well.
Yeah.
And for those of you who have to process the messy web, one of my favorite libraries, Beautifulsoup, just for the name alone, has released 4.13. Amongst other things, this release includes the addition of type hints in the public classes. So it's kind of now easier to use this library inside of your IDE if you dig that.
Cool.
And as you mentioned, we've got so much pep news that I'm going to take a rest. So over to you.
Yeah, I want to mention really quickly that I'm still interested in getting the creator of Beautifulsoup on the show. I talked to their partner a long time ago on the show, and so maybe I'll work that out, but that might be kind of a fun one. But yeah, we have some peps. These peps are ones that are actually being taken off. The first one is PEP 759. It was withdrawn. The title is External Wheel Hosting. You might remember us speaking about it briefly. This one proposed a way to have projects that are hosted on PyPy safely host wheel artifacts on external sites other than PyPy. The PEP only provided a mechanism for projects to customize the download URL for specific released wheel artifacts. It would have used the same dependency resolution that is common in other tools, pip and UV and so forth. So there wouldn't have been any change there. But again, this one was withdrawn. The next one was rejected. This is PEP 2026. the calendar versioning for Python. This one would have updated the way the versioning scheme in Python would have worked. It would have basically followed a calendar year in the numbering. So like after 3.14, which of course we have to do, and it's already in alphas, as we know. This year, that's what it would be. And then the first one would have been 3.26 for 2026, and 27 would be 3.27. And so the idea came because of after 2019, Python has had an annual release cycle, if you haven't noticed. This would allow it to, again, if that schedule is retained, you would know what the current version is, and you also understand the end of life. It's a little bit weird, though, because Python comes out around October each year, so that's literally near the end of the year to name it, but I guess that would be when it was released. Anyway, rejected, so that one was tossed out.
Yeah, I'm kind of disappointed. I like the idea. I don't think it's a earth-shattering one way or the other. I think it was, from what I read of the comments, it was one of those things where most people thought it was good, but there was a couple edge cases that could have gotten ugly, and it just wasn't enough of a benefit to warrant the dealing with those edge cases. So I kind of get it. But
there's a few projects that have done this recently, and it does make you understand like where you are, which I think is kind of handy, especially with so many version numbers floating around.
Yeah. I saw something recently that I've tried to start doing myself, which is in your release notes, if you're using semantic versioning, put a date on your entry so that even if your version numbers doesn't have the date information in it, then at least if somebody's reading the release note, they can get a sense as, okay, was this released from a decade ago or yesterday? So yeah, I get, that information is useful when you're trying to use libraries. So it kind of makes sense.
Yeah. So you got a couple more peps, right?
Yeah. It's ironic that out of the two of us, I'm the negative guy and I'm doing the positive peps and you're the positive one. But anyways, we'll go from there. There you go. So I've got two peps that were accepted this week. PEP 739, which is titled A Static Description File for Python Build Details. It's being targeted for Python 3.14. What this PEP means is that starting with 3.14, each build will include a JSON file containing build information, so meta information, and that file is going to be kept in the same place for all of the releases, and that's basically where the standard lib goes in a release. The file is going to include stuff like, what platform it was built on, the version info, and other metadata. So it's just a common sort of database-y place to keep all this kind of information. This also makes it easier for maintainers who are cross-compiling because they can go, oh, this release was built for a different platform, even if you're not compiling on that platform. So it helps you sort of keep things straight. The other PEP that got approved was 765. This is titled Disallow, Return, Break, Continue that exit a finally block. So this has to do with what happens when you use return, break, or continue when you're inside of the finally section of a try, except finally block. What's supposed to happen is well documented, but it's caused some confusion with some developers. A survey of existing code out there found that this is almost never done, and in the few times it was often doing the wrong thing. So as such, starting with Python 3.14, if you attempt to use return, break, or continue directly within a finally block, you'll see a syntax warning. They also leave the option open of changing this to a syntax error in the future. I think this is one of those that it's purely a safety thing because the behavior isn't what some people expect. I scratched my head when I read the PEP because the behavior they described seemed like the behavior I would expect, but that doesn't mean anything. So whatever. So I guess this is a bit of a foot gun and they're trying to stop people from shooting their own toes off.
At least label it.
Exactly.
Then we'll lock it or whatever. Yeah. All right, cool. Well, that takes us into topics. This first one that I have is from Trey Hunner, who we've featured a few times. And he's created something that's a bit beyond what you might call a glossary. He actually calls it Python terminology, an unofficial glossary. And I found it interesting because at Real Python, we're working on some glossary terms also. We're doing a lot of linking inside of Real Python for that stuff. But there's something that he's going beyond it a little bit, which I like. And he's using terms that are more colloquial used in Python and maybe in lots of other languages. And so I feel like I try to explain some of these, like we just mentioned a bunch of PEPs, Python enhancement proposals, but I don't always spell out every acronym and I try to have guests explain them. but generally a lot of jargon flies by. And I feel like the more and more that you have these kind of conversations, the more that you're leaving beginners and other people out of that conversation by using the jargon. I mean, I think this happens in everybody's life, in every industry. My wife has worked in banking and mortgages specifically, and I'd go to these like get-togethers with her and her coworkers, and they'd speak in jargon all evening, and I had no idea what they're talking about. So I would just start speaking in my own jargon from like audio.
The secret is neither did they. That's just the banking industry.
They didn't understand it. I don't know. They may or may not, but yeah, that's how you can sound smart. Just throw out a lot of jargon. But anyway, so I really like what Trey has created here. He covers a good chunk of things that I feel a beginner or even an intermediate user would need to understand for like having these higher level conversations with other people. So when talking about Python, he's come up often. The thing that's maybe missing out of this glossary, in my opinion, is code kind of showing off this stuff. It's more a big list and then links to other resources. So if you're interested. So I thought I'd just go through a few of them. We use the term float a lot, which again, for a non-computer person, they may not know what that's referring to. Floating point numbers, integers, aka ints, int. The term Boolean is another common one that we throw out all the time, true and false. In fact, you'll even hear the term truthiness and falsiness, which is, I think, kind of interesting, kind of related to that Boolean value. This object is truthy, like it returns a 1 value versus a 0 value. It's kind of interesting. Even includes a link to George Boole, so you can kind of learn the idea of where Boolean kind of came from. Mutation. I think we talk about immutable and mutable objects, but the term mutation is a little weird. The idea that something is changeable and modifiable. Lexicographical ordering. So it's similar basically to alphabetical ordering. Another fun one is file-like object. You hear about that sometimes inside of Python. And then dunder, which I think we talk about often, but the 2 underscores before, like, say, init for initializing. So double underscore init, and then another pair of double underscores. So we call those like dunder methods or special methods, or sometimes people call them magic methods. But yeah, so you hear that double under basically. Terms from exceptions and tracebacks. There's one that I have tried to cover on the show, syntactic sugar, and tried to clarify with Brett Cannon a few times. And then monkey patching, which he mentions in there also, which we just covered a couple weeks ago. And one other one that I think is kind of funny that I think you had a story about, which was the splat, or the asterisk or star that you see and stuff, and how that works in Python. So it's a good glossary. I think there's lots of this sort of jargony stuff that's out there. And like I said, I think this might be handy for our glossary at RealPython to have. So I'm going to try to start the conversation with our team. But are there some favorites that you have?
Well, I think one of the challenges with this kind of stuff is there are things that are Python specific.
Yeah.
And then there are things that are sort of programming language. And then where you get into the messiness, particularly because us as programmers tend to be pedantic people, is different languages will use things subtly differently, right? So like he identifies what a pointer is because people use that term.
Right.
There is no concept in Python, right? Everything's a reference. There are no pointers. And so you can get into these weird conversations where somebody says pointer and then you're trying to say, do you mean reference? And if I understand what they mean, then correcting them just is a sidetrack, right? We
right.
run into this all the time, right? There is a distinction between a constructor and an initializer. And 99.99% of the time, it will not matter. So if you're having a deep conversation about metaclasses and you need to get that exactly right, then it's fine. On the other hand, if somebody calls dunder init a constructor, you know what they mean, so you don't have to correct them, right? So, and I think this is where you run into some of these kinds of things, right? There's the term, then there's the proper technical term. And behind the scenes, some folks at RealPython are writing an article right now, and they're talking about the in concept. And they're talking about, well, does in work on, is it a operate on a container. And well, technically it's not a container because it's more than just containers. It's other things as well. And then you run into the fact that there isn't a single word that wraps it up. So now, if we're having a casual conversation about this, the vocabulary can sometimes help and sometimes it can get in the way, right?
And the beginners and the intermediate people have all left the room because they're like, all right, I don't want to be part of this argument.
Exactly.
I just want to do stuff. Yeah.
So it can get a little funky. So I think having a glossary like this is helpful because as funny as it is, I was thinking, I don't know why I was thinking about it the other day, but it was like, we accept the concept of a string.
Right.
Why? That word has nothing to do with what it is, but it's because it was called that in C, and I'm pretty sure it was probably called that in a language before that, and so many languages are, descendants of C that it's just like, oh, it's a string. Call it a string. That's what we'll call it, right?
I thought that was funny because, just to give an example of one of the definitions, because I didn't really do a lot of defining there. I felt like I'd let Trey get your attention there. But for string, he has strings are a data type used for storing text. Strings are made up of characters, which may be letters, numbers, symbols, white space emoji, etc. And then he's got the link and so forth. So then you'll hear the term substring and the kind of understanding it. So the term string is kind of odd, again, if you're not from programming, right?
And again, one of those places where different languages can muck with you, because in Python, there's technically no such thing as a character, because a character itself is a string, whereas in other programming languages, there is a distinction between a character and a string. So if you're coming from one of those other programming languages, that distinction might be important, but in Python, it's not, because a string of one character is still a string. So the data type is technically still a string, but if I talk about a character, we all know what we're talking about, right? So it gets messy, and the more languages you know, the more likely you're going to be sloppier about it, because your brain uses whatever terminology comes to you first, right?
I always thought that was interesting about the strings too, like the idea that even a single character has every single method that the string class has, like it's kind of wild. And so that is partly why they're overhead. And sometimes, things seem really large, and we look at things like data frames like polars or pandas or whatever, these other kinds of things, thinking of ways to like specify that this data can actually be much, much smaller. It doesn't have to contain the entire objectness that Python presents to it.
Well, and even that causes interesting little borderlines as well, right? So, we're going to be talking about NumPy in a second, but NumPy's got its own data types, and the data types map to C. And most of the time, it doesn't matter. But a NumPy integer data type has a maximum value.
Right.
Integers in Python do not. And for most work, that doesn't matter. But if you start having to swap one for the other and you're dealing with very large numbers, then things are going to fall over, right? So, and yet we still just refer to them all as integers, right? Like the language is looser than I think a lot of people think it is.
Well, we're going to talk a little bit about the creation of Python here in a minute, but I think some of the ideas of that are in there, again, make it friendly and approachable, that all these things kind of behave the same way, and that it's less, I don't know if didactic, but like these different terms that might be used to like say specific stuff, but the looseness of it is kind of what makes it friendly. But there are problems with that, especially when it interfaces with other stuff. And, again, the idea of it being a little slower, and that all depends on what you're trying to do. But again, for people wanting to learn it and develop stuff in it, that's some of the reasons that we really love it.
Yeah. Well, and you see this all over the place, right? So there are languages out there that actually, they're not common anymore, but there are languages out there that don't use zero indexing. They use one indexing because as a programming teaching concept, it makes a lot more sense. We don't start counting at zero. And the reason we do is a historic reason that has to do with how C handles things and arrays and addition. But one of the reasons that didn't take off is because there were enough languages out there that were zeros that it actually caused more confusion, because now you're like, which kind of language am I in, and am I going to swap back and
zero
forth?
Or one base?
So like Python being a friendlier language, I could sort of see them having gone down that path because it's the easier to understand thing. But the flip side of it is, then it makes it harder to interact with C underneath, which Python does really well. And so like these kinds of decisions are, they're basic concepts that the language designers make and have long-term implications.
Yeah. So again, I think it's a great resource. if you're stuck on some jargon or stuff that gets thrown out there, it might be a good link to kind of look at. And again, we're going to continue working on stuff like that here at Real Python too, like where you can go into our search box and type in terms. You're like, what are they talking about? Postman is the world's leading API collaboration platform. Trusted by over 35 million developers and 500,000 organizations worldwide. They just launched Postman AI Agent Builder, the quickest way to build AI agents. With centralized access to the latest LLMs and APIs from over 1,800 companies, plus no-code workflows, you can quickly connect critical tools and build multi-step agents, all without writing a single line of code. Start building smarter agents today with Postman. Visit postman.com/podcast/Python today. That's postman.com/podcast/Python. Well, do you want to start off your next one here? You
Sure.
kind of teased it a little bit about NumPy.
I mentioned NumPy. So my first one this week is a new Real Python video course by yours truly. It's called NumPy Techniques and Practical Examples. This course is a little different. It doesn't intend to teach you NumPy outright, but to show you some real-world problems and how you could use NumPy to solve them. The course covers 4 problems, the first of which is creating multi-dimensional arrays from CSV files. NumPy's arrays can have many dimensions, and since CSV files are only rows and columns, if you're working with data with more than 2 dimensions, you're going to need multiple files. So it starts out with a review of how arrays work in NumPy, and then moves on to how you actually load multiple CSVs. This is done through overwriting a zeroed dimension inside of NumPy using load.txt, and then you loop iterating over a glob of the files in question. From there, it goes on to insert additional dimensions to an existing array using insert, which is a lie because you can't actually insert anything. It copies over them, but that's neither here nor there. And as well as covering the complications you can run into when dealing with glob. So depending on the file names you have, you may not get all the ones you want and probably shouldn't make any assumptions about their order, speaking of lexicographical ordering. So the second problem in the problem set is reconciling data using structured arrays. This is kind of like doing an SQL join, but using NumPy arrays instead. The example uses 2 sets of data, checks issued and checks cached, then uses the ref functions module in NumPy to reconcile across those 2 sets of data. This section also addresses 2 different ways of dealing with duplicate rows in your data. The third problem is charting hierarchical data. And really, it's a quick intro to matplotlib. This is probably the most popular Python graphing library, quirks and all, and it integrates with NumPy nicely. Before creating the graph, you need data to go into it, and the example this time around is stock portfolio data. Like with the previous problem set, the data is spread across multiple arrays, and you learn a couple different ways of working with the data to get it ready for visualizing. And once you've got the data together, then you create a bar graph comparing 2 stock values. And then the final problem is writing custom vectorized functions. The trick to writing quick code in NumPy is to try to keep all the calculating within the scope of NumPy rather than up in the Python world. So for example, if you want to filter the rows in an array, it's better to use NumPy's where function than to loop over the data with an if-then-else statement. For some things like math operations, NumPy has overloaded the Python operators, and so it will do this for you behind the scenes. But if you need your own custom operation, you have to vectorize it. This is a decorator that allows you to transform a regular Python function into one that NumPy can call as an operation on an array. It still isn't as fast as something like where, since your operation is still hitting Python land a little bit, but it tends to be faster than looping, so it covers how to do this and what it means. So if you want to dig into NumPy some more and you're okay with my dad jokes, then this might be worth checking out.
Yeah. If you're having a little bit of deja vu, we did talk about the written article that this is based upon, I think actually 10 weeks back. But anyway, it's by Ian Eyre. And the reason I mention it is he includes some practice that you can do on your own inside of it. So if you take the course, you can kind of continue on from there. And I think there's also an accompanying quiz. So there's some additional resources to practice the techniques that you're going to learn in the video course, which I think is great. So my next one is from our friend Bytecode, who we feature fairly often. And I'll just give the summary. With a little help from Podman, which I'll talk about more in a minute, we can compile the first major stable version of Python. It's surprisingly modern already with high-level data structures. All you need to work with processes, text, files, and the network. But it does have some funny quirks. So the title of the piece is Let's Compile Python 1.0. Python turned 31 years old, I guess January. To celebrate, he wanted to, basically see how the original version worked. And I don't know if you've tried to run programs from even a decade ago, but let's try 3 decades ago. You're going to be into a bit of a shock and a thorough obstacle course of hoops to go through. I just went through that. I was telling Christopher before we started that I tried to revive an old iPod because I love it. It's an old black 5th gen video iPod or whatever it was called. And the hard drive was just basically clicking, but the thing sounds great and I really liked it. So I found this project where you can basically put with an SD card instead. So I now have 512 gig, very lightweight. I replaced the battery too with iFixit. But anyway, I had to connect it to a computer that had iTunes on it. You might know that it's now changed to Apple Music and it behaves really weird with iPods in some ways. But anyway, I happened to have one. I had a MacBook that was from 2012 and I turned it on and fired up and actually everything worked pretty well, except for it started to freak out when it found out that, hey, iCloud's different. And so it thought how it was implemented back then is how it's implemented now. And every other machine that is in my network suddenly freaked out. And it's like, who is this? So anyway, so bytecode takes you through all this stuff, finding the source. It's not on python.org, and started digging around and found legacy.python.org and found some stuff there. He needed something that was similar vintage as an OS to do the build from. It's not going to work in Ubuntu 24.04. Call out to year-based versioning there. Found an old Debian using a tool called Podman, which I was not familiar with. This is a Docker containery kind of tool. In fact, I've learned about 3 different ones recently. Podman is one of them. It's kind of a neat one that actually manages containers and images and stuff inside your local environment. It's kind of a neat one. The other one I heard of recently is called OrbStack, which is another sort of container managing tool. And then there's yet another one that I saw in one of the other projects I was looking at this week. He needed to do updates to that version of Linux. It's changed, of course. He praises the parties that were involved for keeping the stability there. The packages are pretty much the same as they were, which is great. I guess there's some more stability maybe in Linux compared to Windows or things like that. Lots of terminal output that you can follow along as he goes through the article. He finally gets version 1.0.1 to compile and brings up the OG REPL terminology again, read, evaluate, print, loop, your 3 little carrots. And he types print quotation marks hello. It prints out hello. And so it's print statement versus the print function. So things have changed a little bit there. His next thing to try is, let me try typing in help with a pair of parentheses. Name error, help. Uh-oh. So he's on his own there and basically continues on. It's interesting what is there and what's not there. Your experience recently, Christopher, talking about the sockets library might come in handy because it seems to be there. He exits the shell and does a list, an ls lib for the library and sees what's in the standard library. And so it's a fun exploration. He has an ongoing Jurassic Park theme, hence the age of the thing, running throughout. But I think I enjoyed it more from the sidelines. I don't think I'll be compiling it anytime soon. But again, fun experience and neat to see what was in version 1 of Python. I think we've talked about this before, but you've been using Python. I don't know. What was the earliest version you used? 2 something?
Yeah, I think it was 2.6 or 2.7.
Yeah. My first conversations about Python were the team where I asked them, are you guys using 2 versions or 3 versions? What are you guys using? They're like, oh yeah, we're entirely Python 3. I was like, yay. And so I've been blessed to not have to really think a lot about Python 2 in my life. Occasionally it comes up in tutorials and stuff, but real Python kind of has been, for the 5 years I've been working at it, a Python 3 shop. This week, I want to shine a spotlight on another Real Python video course. It's the one that Christopher talked about earlier in the episode, and it's of interest to anyone starting a journey into data science and exploring NumPy. The course is titled NumPy Techniques and Practical Examples. It's based on a tutorial by Ian Eyre. And in the video course, my co-host, Christopher Trudeau, shows you how to create multi-dimensional arrays from data stored in files, how to identify and remove duplicate data from a NumPy array, how to use structured NumPy arrays and reconcile the differences between datasets, analyzing and charting specific parts of hierarchical data, and creating vectorized versions of your own functions. Throughout the course, you'll walk through several examples that'll show you how to use the techniques effectively. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. So what do you got next?
My next article is by Carlton Gibson, who's one of the core Django developers. The article is called Managing Django's Queue, and I originally clicked on it because I thought it had to do with the new queue abstraction, and it doesn't. He's talking about the lineup of things waiting to get into Django release, so different kind of queue. He starts out by linking to an article on queue theory that explains the fact that full queues are bad things. There's math behind this stuff, but in short, if your queue is nearly full, then your processing tends to bog down, meaning the queue will grow faster than you can manage it, which in the software world tends to mean you're going to run out of memory or disk space. In the real world, it tends to mean angry people being denied whatever it was they were lining up for in the first place. So to bring this theory into practice, he mentions that there are currently 954 open tickets on Django and 260 open pull requests. They have one full-time and one part-time fellow working on the code who have to deal with releases, security reporting, community work, and over on top of dealing with all those tickets that I just talked about. So the result of all this is the average wait time for any given ticket is approaching infinity. Some things just aren't going to get done. This backlog led to Carlton remembering a talk by Christopher Nugent-Bauer that dives deep on the different ways that people think about open source and what it means. And one of the points of the talk references a book by Nadia Eghbal called Working in Public. Are you keeping up? I'm talking about a blog post, talking about a YouTube video that mentions a book, and I'm doing all of that in a podcast. So we've got multi-layers of meta reference here.
Yeah, you could do a stack trace on that there.
Yes, yeah, pretty much. And we're going to run out of memory if I'm not careful. The book Working in Public breaks down the projects into 4 categories, and these categories range from low to high user growth across low to high contributor growth. So a low user, low contributor project is called a toy. This would be most of my stuff on GitHub. I'm the only one using it. It's there. Other people can, but I'm the only one using it. By contrast, a high user, low contributor project is called a stadium, meaning you've got lots of people watching a few people working.
Are you not entertained?
Are you not entertained? Exactly. And unfortunately, often the crowd's got their thumb down. We'll get to that in a second. Low user, high contributor is what they call a club, which Carlton mentions is the case for, say, a lot of the third-party Django libraries. And then finally, high user, high contributor is called a federation. Large, popular projects like Django want to be federations, but it doesn't take much to slip down into stadium mode. And that can be a vicious cycle because once you're in stadium mode and the average completion time of an item increases, you're unlikely to be able to clear the queue anytime soon, which creates a bigger backlog, and then you're stuck in stadium mode. So just to make all of this dovetail together, Carlton then finally talks about what it would take to keep Django in the Federation quadrant. And essentially, as with all queues, one of the things you have to do to solve this kind of problem is add more capacity. And one way of doing that is to have more smaller libraries. For example, the soon-to-be-added Django Tasks feature, which just confusingly is an abstraction for a queue manager, is probably why he's thinking about this in the terms of queues. This is currently a sub-library, and it's being maintained separately. And the advantage of that is somebody else could be maintaining it. It doesn't have to be released in sync with Django. And in theory, then it isn't adding to the queue. The downside of that, of course, is what happens if whoever's maintaining it stops maintaining it, and then all of a sudden you've got an interdependency problem of it not being kept up to date. So the closing message in Carlton's article is about people complaining about libraries not being updated. He basically says, oh, you want to use a package that's under-maintained? What are you going to do about that? Are you going to join the club? And I think he missed an opportunity here because really he wants them to join the Federation. But notwithstanding, all in all, working for free for the benefit of others is often an underappreciated thing. And whether you contribute or not, at least show patience and love for your maintainers, because the reason you get at this stuff is because people are putting their time in.
Just even a handful of comments is fuel to keep people running. It's so surprising.
Yeah, and it works the other way too, right? A handful of overly negative stuff, right? Like,
yeah, that's worse. Yeah.
I've seen a couple posts recently about the problems that AI contributions are causing, particularly for security developers, because what's happening is people are starting to run the AI tools against things and say, hey, this is a problem, and they're submitting bugs, and they're not actually properly understanding what's going on because the AI tool said it was, and they can get their little social points on GitHub for creating this stuff.
Yeah.
And then what it's doing is it's adding to the queue because somebody has to go through and go, that is or isn't a bug, right? And I haven't had to deal with this too much on my own with my own projects, but every once in a while I'll get like a commit request. I'm like, you don't even know what this is. I got a commit request about a month ago, somebody insisting that my RST file should be renamed RS because some Rust programmers name their files RST, but the proper thing is RS. And they assumed that this was a Rust file.
This is the
restructured
text or whatever.
Yeah, it was the text format. And so it cost me nothing to reject the pull request. But you think for a large project, when you're having trouble keeping up on tickets and then some random person who just thinks they're being helpful, and of course it looks good on their GitHub profile because they're, look, all the pull requests I've done, and what they're doing is actually causing time for the people who are actually maintaining it. And the more time they spend on that kind of stuff, the less time they can spend on the features that you want in your next thing, right? So
yeah, there's a lot of AI pollution out there. It's pretty crazy. Yeah, I didn't realize that was an interesting gamification thing. I guess that's something to watch out for. So, well, I think that takes us into projects this week. I have a pair of projects that are pretty, I don't know, they're pretty simple. Like there isn't a whole lot to them. I was able to, install them and run them, and I understand what they're doing, and I was very excited about them. The first one is called platformdirs. So the word platform and DIRS, all one word together, get platform-specific directories, basically user data directory and so forth. The project is from the TOX team, TOX, which is a testing environment and tool that is very popular in the Python world. And it's basically underneath their GitHub banner. It's a library to determine platform-specific system directories. So that would include directories like where are cache files and user data and configuration. So we were just talking about, time and computers and where to find things, but also like where things are structured and stored, changes. And it's very different on Mac OS versus Windows versus maybe the version of Windows that you have that you're still running versus all the various flavors of Linux. So this tries to help with that. When you're writing a desktop type application, finding the right location to store user data and configuration is going to vary per platform. And there are conventions that are set up on these. And so the problem is maybe holding all that in your head, and maybe it would be nice to have something that has all that stuff for you. That's the idea behind this library. So for example, if you're running on Mac OS and you wanted to find out where an application should be saved, it's under the tilde library application support and then /app name. On Windows, at least in English, it would be C:, and then Windows, of course, uses slashes, but backslashes. So /documents and documents space and space settings, /user, /application data, /local settings. So if you ever try to find this stuff yourself, you might know what I mean. But even in there, do you then have it as the app author and then the app name? And then similarly, should you put it inside of local settings, or should it just be in the root of application data? So again, the project is under the banner of the TOX development team. It is, as they call it, a friendly fork, a continuation of the work from a project by Active State, which was called appdirs, which has been deprecated. And they note on their contributions are most welcome. It's kind of wild. I mean, you think about it, like as you spelunk through older computers, I know on Windows that storage location has changed over time. So that would be like probably current, I don't know, Windows 10 and up. I don't know. I'm trying to think of like when the shift to documents and settings and this sort of user location happened. But anyway, I was very interested in it, and I thought this would be handy for you, especially if you're trying to set that stuff up for installing locally and using common locations. And then also it finds the other types of directories, like where the cache would be, where the documents directory is, where the downloads directories, where the pictures would be. And so it includes all those user strings, if you will, to find those locations. The other project that Mr. Trudeau shared with me is called Shellingham. And this one it's under the name Sarugaku. It's a collection of community-driven dependency management projects. Again, called Shellingham. And the idea here is that Shellingham detects what shell the current Python executable is running in. So it can determine which shell type, and there's lots of them. So you could type shellingham.detect_shell, and it would output bash, /bin/bash. So it would actually tell you, not only which version of the shell it is, but where it is running from to be able to locate it. So, if you're running ZSH, or there's just so many different versions of shells that are out there, or I guess your end user is, it will return the shell name, always in lowercase, and the command used that would be to run the shell. And if it has a failure in detecting it, it'll let you know that also. So kind of neat project. Again, two sides of a similar coin here, finding where things are running and should be stored on a machine. What's your project this week?
I've got another one that's similar, that it's just sort of a simple self-contained thing. It's called python-sortedcontainers, and it's by Grant Jenks. The project more or less is exactly what it sounds like. It provides a sorted implementation of a list, a dictionary, and a set. It's been around a while, so the dict has kind of become redundant, but sorted lists and sets are still valuable. The nice thing here is that the implementation is pure Python, which makes the library a little more portable than some of the others that try to solve the same problem. Each of the containers have create, update, and delete operations that keep the container in a sorted state regardless of the change you make. So, with the list, you pass in a regular list, it sorts it, keeps it sorted, and as you add or modify it, it stays sorted as you go along. There's not much else to say about this, but if you need sorted stuff, and rather than do it yourself, this library does it. It's been around for a while. And it seems to be pretty solid. So it's worth checking out.
Nice. All right. Well, that brings us to the end of another episode. Thanks for bringing all these articles and projects this week, Christopher.
Always a pleasure.
All right. Talk to you soon. And don't forget, Postman is the world's leading API collaboration platform. And they just launched Postman AI Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.